Hello, everyone. How is your summer going? Thanks for joining us this morning. Who all, who all the people who are joining us right now, please share in the chat where are you joining us from. I know this community is so cool, but we want to make a friendly reminder of the code of conduct. We are committed to providing a friendly, safe, and welcoming environment for all, regardless of gender, sexual orientation, ability, ethnicity, socioeconomic status, and religion or lack thereof. Participate in an authentic and active way. In doing so, you contribute to the health and longevity of this community. Exercise consideration and respect in your speech and actions. Attempt collaboration before a conflict. Refrain from demeaning, discriminatory, or harassing behavior and speech. Be mindful of your fellow participants. And remember, there is no such a dumb question, and it is okay not to know about everything. Please hear our land acknowledgement. We would like to acknowledge that we are based on traditional lands referred to as 3D6 territory, a traditional meeting grounds, gathering place, and traveling route to the Cree, Saulteaux, Blackfoot, Métis, Dini, and Nakota Sioux. We acknowledge all the many First Nations, Métis, and Inuit whose footsteps have marked these lands since time immemorial. This is the plan for today, as we are having the introduction right now, followed by our hands-on workshop, getting started with agents through MCP, ADK, and A2A, and follow for the Q&A and the farewell. Let me introduce ourselves. We are GDG Cloud Edmonton. We are an official chapter of Google's worldwide network of cloud enthusiasts, developers, data scientists, and engineers. Our team is integrated by Rohan Saha, Ndidi Obingwani, Temitope Ajiboji, Jonathan Pu, and me, Vania Hanatyuk. For all the folks who are joining us out of Canada, let us tell you about Edmonton. We are just a little bit north of the planet. We are located in the capital of the Canadian province of Alberta. In the picture, you can see one of our iconic landmarks, the Waterdale Bridge. We are home of the NHL hockey team Edmonton Oilers. Additionally, Edmonton is considered in the top 10 of cities with best pizza. Where important pizza restaurant chains were founded like Boston Pizza, Famoso. And lastly, we are north enough to witness the stunning northern lights. Now we are going to start with the best part of the day. Let me introduce our great instructor, Rohan Saha, who is a PhD student at the University of Alberta, where he studies how transformers learn and represent information. His research focuses on latent structure learning and mechanistic interpretability with the goal of making AI systems more understandable and reliable. Outside of research, he's always happy to chat about AI, machine learning, and the latest developments in the field. Please give up a warm welcome to Rohan. Now, Rohan, how is your morning going?
So it's going pretty good, I would say. Yeah, it's pretty sunny here, so I'm happy.
Yeah, it looks really a nice day. And let me pass it to you all along.
Okay. Okay, so I was thinking of actually pasting the link for the codelab in the chat. And I'm going to share my screen. Wait, let me just quickly share my screen. Okay, so you should be able to see my screen. I'm sharing the Google Cloud Console. And I think it would be best for me to do a code along so that you guys can also do the code along on your own pace. And once you hit a snag, we can actually discuss and resolve issues. I'm going to go through the code along. I'm going to go to the tutorial and I'm going to explain the concepts, and then I'll actually show how it works on Google Cloud. Okay, so the goal is to actually have some understanding of how MCP works, what is an MCP, how we can create an LLM agent. We can query an LLM agent and it will do some action for us. So that is the goal. So let me just quickly paste the code lab in the chat.
I'm pasting it for you.
Okay, you pasted. Okay,
Yeah,
that's good.
yeah, don't worry.
Right. Okay, so feel free to open the code lab, and I'm also going to open the code lab on my computer as well, so that we can actually go through the different instructions step by step. Okay. So let me just share this tab instead. Okay. Right, so there are multiple steps. Hopefully, an hour should be enough. But if people need a break, we can stop in between. And if people have questions, just feel free to unmute yourself. Everybody should have access to unmute themselves and speak. If not, if you want to type it in the chat, that's fine as well. Okay, so let's start.
Rohan, would you mind to zoom in your screen, or anyone in the chat can let us know if you're seeing good the font and the Rohan's screen.
Is it tiny?
Well, here in my screen it looks tiny, but I'm not sure about our attendees. Oh, Christopher says it looks great.
Okay. Okay. So will the interface to the agent be CLI or web-based? There are both of the cases are there in this code lab, so we can look at both of them. Okay. I think the ADK, yes, the agent development kit actually does expose a web interface using which you can communicate to the agent. But yeah, we'll go through these things one by one. Okay, so let me zoom in here. Okay, yeah, you can zoom in. So this is the architecture that we will try to implement. So there will be a user, an agent. An agent is an LLM, and the MCP is akin to a REST API that the LLM will actually use to get some information. And then multiple agents or multiple LLMs can communicate with each other using the A2A protocol, so agent to agent protocol. And everything will fit together. And then we will have an autonomous system, not really autonomous, but close to autonomous, where you can have an LLM agent that will interact with another LLM agent to fetch some data and do some processing. And the concepts that we will end up learning are the model context protocol, agent development kit, and the agent-to-agent protocol at a very high level. And then there are many other resources in the code lab that you can go and explore on your own. So we will start by first doing some installation and setting up Google Cloud Console so that we can actually write the code and deploy the code so that we can have an application or a Docker container that runs on Cloud Run, and we can interact with that. Okay, so let's go to Google Cloud Console. Let me switch my tab. Okay. So when you go to Google Cloud Console, so console.cloud.google.com, if you haven't created an account, go and create an account. And I'm assuming that everybody has a Gmail account, everybody has a Google account, so they should have access to Cloud, Google Cloud. So when you go to the home screen, you should see something like this. And then on the top left here, you can click on this icon or button, and this modal will pop up. You can click on new project. And I have already created many projects, but if you don't have any projects, you can go and click on a new project. And then it will actually take you to the screen, and you can add a project name, you can add an organization, you can keep it at an organization, and then hit on create. So for doing this codelab, you need to have billing enabled. You won't get charged, but you just need to add a payment method. But you won't get charged because the resources that we will use, they have a free tier. Okay. So you should have this project dashboard. Once you have created the project, you will see something like this. And you will see a project number. You can see the project ID. And these things are important. So what we are going to do, okay, nobody has any questions so far. So I'm assuming everybody, this is pretty simple. Okay. So what we're going to do is we're going to click on this icon and it activates the Cloud Shell. So this is terminal that is running on the cloud. So we're going to click on this. We're going to click on authorize. And it will say provisioning your Cloud Shell machine. And now it's connected. So now we see a terminal. So this is a Linux machine. So we can enter Linux commands. It will work just like a Linux machine. And I'm going to remove the currency agent because I already did this once and the folder is already, so we can start from scratch. Okay. So first we want to see if the projects that are authenticated for this account, this Google account, are they actually listed?
Rohan, here our audience is asking us to go a little bit step back. They need to know where to start again, please. Thank you.
Okay, so I'm going to assume you have the project created. If you don't have the project created, click on this icon here in the top left and click on new project. And once you click on new project, it's going to take you to this page and then click create. Okay. And then after you have created that project, you should see something like this. So it will say you're working in your project name. And then after you have this, you click on the top right here. It's grayed out because the Cloud Shell is activated. If it's not activated, it won't be grayed out. And so you click on this and this terminal will show up. Yeah, so click on this top right to activate the Cloud Shell. Okay. Now that we have this, what we're going to do, we're going to type in gcloud auth list, and this will show the accounts that are active. So this is the account that I'm currently working on right now. And then I'm going to set an active account. So I'm going to enter this command, so gcloud set account, and then I'm going to enter my email address. Okay, and this should work. Okay. So hopefully everybody is done with this step. Now what we're going to do is we're going to type in gcloud config list project, and this will list the projects inside this account. Okay, so this is the project that we're currently working in. You might see some HTTP request failed errors. No need to worry about this. If you do see this happen, I think you can just re-log in your terminal shell. I had this problem yesterday as well, but this is nothing to be worried about. So yeah, you could just type in gcloud auth login. So I'm gonna do this gcloud auth login, and then I think it's no launch browser. Let's see if this works. No launch. Wow, cannot spell browser. No launch browser. And then I'm going to type in yes. It will ask me to open this tab. If you click on this, it will open a new tab. And then you log in with your account that is for this Google Cloud Console, or the Gmail account or Google account that you're working with right now. And then in the end, once you click through the login instructions, it will give you a code. So copy that code and paste it here. And then you most likely shouldn't get that HTTP error again. Okay. So let's see, let's do that again. So gcloud config list project. Okay, I don't get that HTTP error again, so I think it's fine now. But it might happen again when we open other terminals. Okay. So now we're going to set some environment variables. So we're going to do export project ID. And I'm going to type in MCP 2row, which is essentially this. Okay, so export project ID. I'm going to hit enter. Now this project ID environment variable is set. I'm also going to type gcloud config set project to the project ID. This should also work. Okay. Now, to actually do this codelab, we need a lot of services enabled, a lot of APIs. So we need to enable a lot of APIs. If you go to the codelab, you will see a command that enables a lot of APIs, such as Cloud Run, such as the build platform, which actually builds the container that is deployed on Cloud Run. So we need to enable these APIs. So what I'm going to do, I'm going to type this command in the chat.
Would you mind to show which stage you are in the code lab so they can see in which step we are at us?
So I'm in step 2 right now. I'm going to share this. I'm in step 2 right now. And this is the command that we should be executing. Okay. And I'm also going to put the command in the chat. But yeah, the actual backslash characters, config location specs failing. Maybe you can okay, so if there's an error, there's another way of actually resolving the errors. What you could do is you could go back to so you can click on this Gemini Cloud Assist chat. It's going to bring up, I don't know if it shows up here. Yeah, it does show up. So it's going to bring up this Cloud Assist, and then you can type in your error here. Just copy paste the error here. It's going to give you a resolution. So see if that works. If it doesn't, then we can actually debug it more. But usually re-login works, and it should resolve the issues. Okay, so now what we're going to do is I'm going to go back here. I'm going to paste, close this. I'm going to enable the services. It's going to take a while, maybe 10 to 15 seconds. Oh, it's pretty quick. It's done. Nice. So now these operations, these APIs have been enabled. Now we can use them. So by default, any Google Cloud project doesn't have the APIs enabled. We need to enable those APIs if we want to use them through this Google Cloud project. Okay. So now we have completed step 2. So everything is set up. And now we will actually install and download a Git repository where the code for the agents are actually there. So now I'm in step 3. I'm going to first clone this GitHub repository. So you can just copy this. And I'm going to go back to my Google Cloud Console. So in the terminal, I'm going to copy and paste this. So this is the GitHub repository. So let's see what happens if we click here. So this is the GitHub repository that actually has the code. So there are multiple folders here, and we're going to work with all the folders. And inside each folder, there are different Python scripts, and we're going to understand what the code is inside the Python scripts. Okay, go back to the Google Cloud Console. I'm going to hit enter. Okay, currency agent has been cloned. It has been fetched from GitHub. And now it should show up here. So yeah, currency agent actually shows up here. It is okay, we are also already inside currency agent. So this is the currency agent GitHub repository. It has been cloned. And then inside currency agent, there's also another currency agent, but there are like also other folders as well that we are going to look into and understand what the code is. Right, so I just want to make sure that everybody, is my screen share frozen? Okay. I don't think it's frozen. But yeah, if it is, if there's a problem, we can resolve it later. Okay, good. So now we are going to install UV. UV is a Python package manager. It's like virtual environment or VNV or Anaconda, if you have heard of Anaconda. So UV is better because we don't have to manage virtual environments, and it manages and installs the dependencies during runtime when you actually run the code. So it's pretty nice. So what we're going to do, we are going to, because this is a Linux machine, we are going to copy this command. If you're on a Windows machine, which if you're working on Google Cloud and if you're on the Cloud Shell terminal, it shouldn't be the case. But if you're doing this locally, you would use this command. But since we are on Linux, we will use this command. And then we'll go back here, and then we're going to just install UV. So this is the, let me go to Astral. So if you're interested in learning about UV, you could just go to astral.sh, and then it will show you how to use UV. Let me see if, yeah, I'm gonna paste it here if you're interested in checking it out. So yeah, this is nice. I would recommend using UV if you work with Python. It's good and it manages the dependencies during runtime. Okay, so let's go back to Google Cloud Console. I ran this command and it says everything installed, so we should be good. Now we can actually run the Python script and we don't need to worry about the dependencies. Okay, this part is a bit tricky. We need to set the environment variables. And hopefully if you just copy paste this, it should work. And we shouldn't be having any problems. But people have told me before that this could be tricky. So I'm going to take this, click on copy, and then I'm going to go back to my Google Cloud Console. I'm just going to paste it in the terminal. So it is done, and let me see if can I actually, yeah, so this is the content of the env file. So these are the environment variables that Google Cloud actually uses behind the scenes to make sure that everything's working perfectly. So make sure you have this step done. Okay, so I'm gonna move to the next step, which is actually creating the local MCP server. Okay, so MCP stands for Model Context Protocol, and it is essentially a fancy REST API. And the way it, okay, so the purpose of the MCP protocol is to give LLM agents some way of understanding what the different functions are for a specific service. So it is close to a REST API, but instead of the user actually typing in the different values for the different keys in a REST API, we offload that part to an LLM, and we use the LLM as a reasoning engine, and the LLM decides, okay, this is the function I should be calling in order to solve this task. So at a very fundamental level, it's close to a REST API, and I will look at the code and we can see that, okay, it's very close to a REST API. So actually, let's look at the code. So in the code lab, you can see there is this code, but where is this code? So what we can do is we can open editor here by clicking on this button. So, and it's going to say connecting to, sorry, I should go back here, right? Yeah, so there should be open editor here instead of open terminal. Okay, let me see. So this is where we started, and then open editor should be here. So we're gonna click on open editor, and this is what will show. This is how it's gonna look like. If you work with VS Code, this is VS Code essentially. Okay. So on the left, you would have multiple folders. You might only see currency agent. You won't see companion Python. This is from another project, so you can ignore this. So you will see currency agent. This is the GitHub repository that we cloned from GitHub. You will see this. And then inside currency agent, you will see other folders as well. And then, let me close this, and then we can just start from scratch. So under MCP server, you will see server.py. So we can click this. And this is the code that is on the codelab here. So this is the MCP server.py file. And so this is a Python script, and fast MCP is a Python library that allows us to define MCP servers. And you can see that this is essentially a function. So this is a tool that the LLM will call. And the LLM actually has or is given this information about this function so that it knows what to do or how to call this function if it needs to call this function. So it tells the LLM, okay, use this to get the current exchange rate. So let's say you want to convert between two different currencies. You will call this function to get the conversion rates. So by default, there are some currencies here. But if you ask the LLM a question, okay, convert from USD to Canadian dollar or Australian dollar, then it will call this function, but it will pass in different values for these two variables here. And then it does a lot of internal processing. So it actually calls the API, the REST API, which is frankfurter.dev. And then it passes in the parameters. So this function actually calls this, but this function is called by the LLM. And then it gets a response, and then it returns the response to the LLM, and then the LLM takes that response and does some natural language processing and gives you the answer. So instead of you as a user who is going to call this API, you ask the LLM, and then LLM knows, okay, this is the function that I should be calling, and it does that for you. So that is an MCP server. So this is an MCP server that has been created for us. And so let's start this MCP server. Let me see if there are any questions. Okay. No questions so far. So we are going to start this MCP server. So how do we actually start this MCP server? So you should see the terminal here. And so what we're going to do, we're going to cd into currency agent. So make sure you're inside the currency agent root folder, not this one, but this one here. And then we'll do UV. We install UV, which is a Python package manager. Also, it allows us to run Python script. So we will do UV run, and then this Python file is inside MCP server. So we're going to do MCP server and then server.py. This should work. Okay, so it installs all the packages and it creates a virtual environment. We didn't have to manage any virtual environments, and it creates the virtual environment and it runs the code. Okay, so fine. I think the code is running. But if you actually go to this website, I don't think you will be able to. It will probably give you some error. So yeah, if you go to the website that was in the terminal, it should say not found. This is not a problem. This is how it should work. Why? Because the MCP server actually requires, or the tool or the function needs to be called in a certain way, and we are not doing that. So it's fine. Now we are actually going to test this function through another Python file. So we want to see whether we are going to simulate an agent by writing a Python script, and then we will run the Python script so that it calls this MCP tool just to make sure that this MCP is working. Okay. What I'm going to do is I'm going to click on this icon, and this splits the terminal. So you can see this same terminal. You can see another terminal that is next to it. And now we are going to run test server. Okay, so let's go and see test server. I'm going to open it up here on the right so that we can see it side by side. Okay, what does test server do? So it creates a client object, which is also inside FastMCP, and it does an asynchronous call in main. And this MCP server is running locally on this machine at this port. Okay, and what it's going to do is it's going to call this function on the left here. So where is it? So this is the name of the function. And this is the currency from, which is this variable, this argument. And this is currency2, it's euros. So we can change this to something else. So let's say CAD. Yeah, so instead of USD to euros, let's see if it works for USD to CAD. So these parameters will be decided by the LLM, and you don't have to do it on your own. So if you ask the LLM, okay, convert between any two currencies, the LLM will decide what the currency code is, and then it's going to call the function accordingly. Okay, so hopefully this works. Let me run it here. So I'm going to do UV run MCP server test server. Okay. So we can see the logs here for the server. It returned a 200. Okay, we're good. And then, okay, it says USD to euros because the print statement here is USD to euros, but we can see that it actually returned USD and CAD. The exchange rate is of yesterday, so 2026, 10 July 2026. Okay, so now you can play around with this if you want to try out different currencies. But yeah, so now we tested that the MCP server works. Now we will deploy this MCP server. So it's currently running locally, but now we need to deploy on Cloud Run so that we don't have to keep this Cloud Shell open if we want to access the MCP server later. We can just call the URL that is running on the Cloud Run, and then we can access it from anywhere, or anyone else can also access it. Okay, I'm going to pause here to see if there are questions. Okay, doesn't seem like people have questions. Oh, pretty straightforward. Okay, cool. Okay, so now what we are going to do, we are going to, I'm going to go back to the codelab now. And I'm going to stop the server. Let me stop the server. Let me go back to, okay. Okay, make sure you stop the server. So let's stop the server. So how do you stop the server? We just do Control C if you're on a Mac. Okay, so now it's stopped. Right, so now we need to deploy this to Cloud Run. So we are in the top level root directory, which is currency agent. And we will have to go into the subdirectory, which is also called currency agent. Okay. Sorry, we will actually go into the subdirectory MCP server because we want to deploy the server, not the currency agent. So we will go into MCP server. Okay, so now this is the directory we are inside in, and we will deploy this onto Cloud Run. So how do we deploy this? So we can actually, if you want to, you could just copy this command. What does this command actually do? So make sure you're inside MCP server, otherwise it won't work with you on your. So we can just copy this and paste this, but let's try to understand what's happening here. Okay, so it's a gcloud command, and you do run. So it will deploy on Cloud Run, and then you deploy this MCP server. It will deploy MCP server. MCP server is the name of the container that it will package up the code into, and then it will deploy onto Cloud Run. So Cloud Run is a machine. You can configure the machine as you like. And now instead of running the server locally, it will run on Cloud Run. I think I already have an MCP container called MCP server, so I'm going to change the name to something else. MCP server 2. I might have created MCP server 1 as well, so I'm going to change it to 2. Okay, this part is important. No allowed unauthenticated. This means that only authenticated users are allowed to access the MCP server. This is the region, and then the source dot is you package everything that's under this folder. And then you can see this has a Docker file. So the Docker container or the Docker program will actually use the Docker file to create a container. It will package everything up, and then it will deploy to the Cloud Run machine. So let's see if this works. It should work. Okay, it's giving me the HTTP errors. Let's see if this works. If it doesn't, then I'm going to have to re-log in and then run this command again. But I'm not going to stop this command yet. Yeah, I think we have 2 million requests per month for free. And then if you have more requests, I think it auto scales to handle the number of requests. But maybe you could just check the Cloud Run documentation, and then it should give you a better answer. Okay, I'm gonna wait here to see if it actually is building. There was a link here where it should tell me where it's building. Yeah, so I think this is where it's actually doing the builds. Let me see. Oh, I don't know why channel this. Interesting. Okay, it did say that it deployed. Okay, let me copy and paste this and see if it actually works. Okay, so if you actually copy and paste that link from the terminal here, I mean, this link should be different for you. And you copy and paste it into the URL bar, it should take you to a web page like this. And then this is the build log, where it shows that, okay, the container that you, or the Python packages have been successfully packaged into a container, they have been deployed onto Cloud Run. So this is the build history. Okay, and then it should say done here. It should not throw an error. Let me see if. Okay, so I'm going to answer that question about the free tier or not. Maybe I can go to Cloud Run and actually show you that. So yeah, I think this is a good point to actually pause and go to the Cloud Run application. Let me see if Cloud Run, okay, I'm going to click on Cloud Run here. So go to the navigation menu and click on Cloud Run. So you will see that I have already deployed multiple containers here. And if you do not want to be charged, you can see these are inactive. These resources are inactive. What you can do is you can go to the container that you just deployed. You get 2 million requests per month for free. And what you can do is you can go to the, click on the container that you just deployed. You can click on this pencil icon, edit service level scaling settings. You can click on this, it will open up this sidebar, and you can click on manual scaling. You can set this to 0. Okay, so this will disable the service and you will not get charged. Okay, I'm going to click on cancel because I want to continue the code lab. One thing to note here is that, let me go back here. You cannot delete these instances. You can only set the scaling to 0. And scaling essentially deactivates the instances, but you cannot delete them. So this is something to be mindful of. But if you set the scaling to 0, it will be inactive. You won't get charged with a bill. But again, for the purposes of this code lab, 2 million requests is too many requests. And so we will never use that many requests for this code lab. Okay, so let me just go here. And then you can see a lot of metrics. So you can see the request count. So request count, I don't have any data because I never called this container. I did not send any requests. But I also have other MCP servers here. And I think for this one, I created some, let me see if the MCP server, okay, this one, yeah. I should have some requests. Yeah, so you can see there's like some spiky activity here. This essentially shows the request count and how many requests per second, essentially. And there's a latency, etc. information. But yeah, you can like explore this and see if you go over 2 million requests a month, which won't happen in this code lab. Okay, let me go back to the editor. Okay, so now the URL, this is where the container is deployed. So initially the server was running locally, the MCP server was running locally, but now it's running on Cloud Run. Okay, now we need to access it somehow. Okay, so because it doesn't allow any unauthorized applications or clients to access the MCP server, for the purposes of this code lab, we are going to set up a proxy that essentially reroutes all traffic to the local host that comes to localhost to the Cloud Run, the container that is deployed. So let's say on this terminal on the right, we are gonna set up a client, LLM client that calls the localhost server, but localhost server doesn't have anything running and it's being run on Cloud Run. So what we're going to do is we're going to just essentially route the traffic from localhost to the container in Cloud Run. Okay, so I'm going to go back to the code lab and I'm going to run this command. So I'm going to copy this. I'm going to paste this. But if I understand this correctly, my MCP server is actually called MCP server 2. So I'm going to change this to 2. And hopefully this should work. So I'm going to hit enter and then see what happens. Okay, so it does say proxying to Cloud Run service MCP server 2 in project MCP Turo in this region. And this is where it's sending the requests to if I get a request in localhost. Okay, so I think this is the right URL. Let me double check. Okay, so I think this should run.
Rohan, here we are only seeing the code lab page, not the terminal.
Oh, you are not, okay, yeah.
Thank
Can
you.
you see it now?
Yes, now we do. Thank
Okay,
you.
so what did I do? I just ran this command. So make sure this name matches with the name of the container that you deployed on Cloud Run. And then you should see something like this. So it should show proxying to Cloud Run services in project so and so. And then it should also show you the link. So let's see what happens if I click on this link. Okay, so if I click on this link, it opens up a new tab. I'm going to go to this tab and it should show forbidden. This is fine. I think it's fine because we cannot access the server through this URL. We need to add something else to the URL in order to call the function. Okay, so I'm going to go back to the Cloud Shell. Now let's try to actually run the test agent again. So I'm going to go here. You should be able to see the terminal. Okay, so let me try to do UV run MCP server and then test server. Okay, so it works. So what happened here? So this test server, you can see that the client is running locally here, or the client is getting the URL of the server that should be running locally, but there is nothing running locally here. The container is deployed on Cloud Run. But since we have a proxy on this terminal on the left here, it's routing all traffic, the whatever comes to the local host to Cloud Run. So that's why this test underscore server.py function call actually worked, because we have set up a proxy. If we had not set up a proxy, it wouldn't work. So you can actually press Control C here and then try it again. It should not work. Okay, so now what I'm going to do is I'm going to go back to the codelab and let me see. Yeah, so now what we're going to do is, instead of calling the function or the MCP tool manually, we're going to have an agent or an LLM actually call this. So you're going to interact with the LLM, and the LLM will call this function instead of us calling the function manually like we did here using this Python script. So I'm going to pause here because it's already like 40 minutes. I think the cognitive load is a bit high. So I'm going to take a 2 to 3 minute break and see if like everybody's on the same page. Then we're going to come back after 2 minutes. But yeah, feel free to go through this page, step 6 of the codelab, and try to get a basic gist of what the codelab actually, or this page actually does, and then I'm going to go through the rest of the codelab. Okay, see you in 2 minutes. Okay, Okay, so the server is, we are back. Hopefully people had a nice 2-minute break. Okay, so the server is deployed on Cloud Run. And now we need to create an LLM agent that will call this MCP server and do the currency conversion for us when we ask the LLM some question about currency conversion. Okay, so let's do that. I'm on the codelab, and there's a lot of Python code here. Actually, not a lot. But let's try to understand what this code does. So I'm going to go back to my Cloud Shell. And this LLM agent is inside currency agent on the left, inside agent.py. So this is where it opens up. Okay, I'm going to close the terminal. So let's try to understand the code. Okay, so there's a lot of, there are some Python packages here that are being imported. Cool. Okay, the environment variables are being loaded. Okay, system instruction. So what is a system instruction? For any LLM, there's a system instruction that essentially tells the LLM how it should behave at a very high level. So this is prompt engineering. You're telling or giving the LLM a specific role. Obviously, this does not change the underlying training distribution of the LLM. It just tells the LLM to behave in a certain way, and it does that to a reasonable extent. Okay, so you are a specialized system for currency conversion. It tells you, okay, you're a currency conversion specialist. There's the sole purpose, and then it also has another instruction here, which is like, okay, do not attempt to answer unrelated questions or use tools for other purposes. So I'm very interested to see if the LLM actually denies or actually does not answer any of the questions that are unrelated. So if I ask an unrelated question, it should answer that, oh, I'm not authorized, or I don't know. But we'll see. It's like a fun side thing to check. Okay. So loading MCP tools from MCP, these are just logs. Okay, how do we actually define an LLM agent? So this LLM agent class is from the ADK library that Google has developed. So using the agent development kit or ADK library, you can define multiple LLM agents. And then you can assign a role to each LLM agent. And these different LLMs would have different roles. They would do different things. So this is not creating an LLM, it's just instantiating an existing LLM and giving it a role. Right? So this is the same model. You could add any other model here. You could add any of the other Gemini models. You could add GPT. You could have Claude. You could have anything. You could have the open source models as well. And this is like a wrapper that takes the model and gives it a role. And that's all it does. You could also give it a name. So this is just a label. It doesn't do anything to the LLM. It's just a label. The underlying model is still Gemini 2.5 Flash. And this is the description of the model or the LLM agent. The system instruction is given here. Right? So whenever you start a new chat on ChatGPT or on Claude, it is filled with the system instruction in the beginning. And we can also say what tools does the LLM have access to. It can have access to the tools that are defined in the MCP server that is hosted on Cloud Run. But here the URL is pointing to the local host, but we already have a proxy set up that goes to the Cloud Run deployed container. So essentially these two things are the same. Okay, so you can see the proxy is still running, but the container is deployed on Cloud Run. So essentially this points to the container deployed on Cloud Run. Okay. And we also are going to make the agent A2A compatible. We are going to discuss A2A but later, but we can ignore this for now. Okay, so what do we do now? So we are going to run this LLM agent, and we are going to interact with this LLM instead of directly calling the MCP server. And then we hope that the LLM understands what we are asking it to do, which is currency conversion, and then it will call the tool that is deployed on the MCP server running on Cloud Run. Okay, hopefully this makes sense. Yeah, I think the recording will be available to watch, but I think Vanya can answer that question. Okay, so
Yes.
I'm going to.
Sorry, yeah, there will be a recording.
Okay. Okay, so I'm going to do that now. I'm going to see if the agent is running successfully. Okay. I'm going to clear this terminal on the right. And I'm going to run UV run inside currency agent. Okay, so make sure I'm inside. What's the directory? Okay, so this is the root directory. I'm going to run UV run ADK web inside the root directory. And let's see if this works. Okay, something's happening. It did not throw an error. So let's wait a little bit, a few seconds, and see if it works. It's taken a while. Okay, it's done. So it says ADK web server started. For local testing, access this link. So let's see if I click on this link. Okay, if I click on this link, okay, you are able to see this. Okay, so let's see. You should see a black screen. And then on the left, we can see a drop down, select an agent. So these are essentially the folders inside the currency agent GitHub repository that we cloned. And we're going to click on currency agent. And then it's going to bring up a chat interface using which you can chat with the LLM agent. Okay, so let me try to explore what's in here. Events, states. Let's turn on token streaming. You can also delete the current session. You can attach files. Okay, you can states where. Okay, so let me try to. I don't know. Can you please convert 10 USD to CAD? Let me see if it actually does this, even though it only has access to convert the currency but not do any more calculations. I just want to see if it works. Okay. Okay, so it calls get exchange rate. It received a response from get exchange rate, and this is the MCP server that we saw originally in the beginning of the codelab, and this is deployed on Cloud Run. So it calls that function, but it actually calls localhost. But the localhost, all the traffic that is going to localhost is routed to Cloud Run. Okay. So it calls the function, and then it retrieves the data, and it gives me the exchange rate, and then it does the conversion. But I don't know if it actually did this conversion, but or like it just inferred that this should be the output. I don't know if it actually used a calculator function. Okay, so there was another part of the system prompt where it said, do not answer any unrelated quiz. So I'm actually curious to see what happens here. Let me see, what model is this? Oh, it did say, okay, I cannot help you with that, which is fun. Okay, so now we have a way of actually testing the LLM agent. So now we have shown, or we have had a conversation with the LLM agent, and the LLM agent is calling the MCP server. And you can see this is like 200 OK, some logs here, which essentially shows that nothing's broken. Cool. I'm going to pause here just to see if people have any questions. I don't see any questions in the chat, so I think they should be fine. So yeah, if you are creating your own LLM agent, you can use ADK to make your own LLM agent to do whatever you want to do, and then you could host all the MCP servers on Cloud Run. You could also host it locally, and then you would interact with the LLM agent using natural language, and then it will do some things for you. Okay, so what is the purpose of UV Run ADK Web? It just gives you a web interface using which you can interact with the language model. So it's essentially a chat UI like you see on ChatGPT or Claude or DeepSeek. But this is an LLM agent that you define using the ADK library, and you're interacting with this LLM that has this ability to call functions. Okay, let me go back to the Google Cloud, not the console, sorry, the codelab. So here I am on the codelab. And so we already did this. We clicked on the currency agent. We asked it a question. It gave us some answer. And now we can see that the LLM actually does currency conversions. So now let's move to the A2A protocol. So what is the A2A protocol? So the A2A protocol was designed or has been created to essentially establish a standardized way for multiple different LLMs to communicate with each other. So this is important because different companies might implement their own LLM in a different way. And then we want some kind of standardized protocol to make these LLMs communicate with each other in some consistent manner. If all the protocols, if every company or every LLM has a different protocol, it might be difficult for LLM to LLM, or difficult to have a communication, difficult to have a way to communicate between LLMs. So that is essentially the reason why the A2A exists. It just establishes a standardized protocol. So one thing that is important is the agent cards functionality. Essentially, it says, okay, what the agent or the LLM is capable of. So it could list out all the tools and the abilities that this specific LLM is capable of. And there could be another LLM that is capable of something else, but not the abilities or the capabilities that the first LLM has. So the agent card essentially describes the capabilities of the LLM in a standardized manner, and then any other LLM could understand what this other LLM is doing just by reading the agent card. So it's like a standardized protocol. Okay, so this is an example of an agent card here, where you have the capabilities, the skills are also there. You can have multiple skills. If there's some authentication protocol that the LLM needs in order to be communicated with, it also is there. And this allows a system where you could have multiple LLMs and they could interact with each other in order to solve a certain task. Okay, this is especially helpful when different businesses have their own LLM. So if you want to communicate with the agents of another business through your own agent, through your own LLM agent, this is helpful because now they have like a shared language to communicate. So we can actually give our LLM agent, which is the currency conversion LLM agent, an agent card, and that will make it closer to following the A2A protocol. So let's do that. So on the codelab, you will see there are like these different skills that we saw in this agent card. So this is This is a skill. So we can define a skill, and then the skills actually go into the agent card here, and this becomes part of the agent. So let's try to do that. Okay, I'm gonna go back to my cloud, Google Cloud. Okay. So now we are going to open up agent.py, and then, okay, the A2A function actually does this, so we don't have to write any more code. So this A2A makes this LLM agent compatible with the A2A protocol. So now if any other LLM agent wants to communicate with this LLM agent, it knows how to communicate because now it's part of the A2A protocol. Okay, so now what we're going to do is we are going to open up a new terminal. So I'm going to stop this. So this was the ADK UV run ADK web command. I stopped that. And now I'm going to run, let's say UV run UVcorn, UVcorn. And then I'm going to run the currency agent dot agent. So inside currency agent, I have the agent that is exposed at the port 10,000. And then I'm going to, you could also like copy paste the command that is on the codelab, but I'm just typing it out because I want to understand what each element does. Okay, so, and I'm going to do currency agent colon A2 app, which is this line. I'm going to expose this. It's running on localhost, and I would like to expose this on port 10,000. Let's see if this works. Okay, so it didn't throw me an error. I think it's working. Okay. Now, this is an agent that is running. We cannot, we can communicate with this agent, but the ultimate goal is to have another LLM communicate with this. But I don't think that is something that we're going to do today, but we can actually, because we defined a system card using the A2A function, an agent card using A2A function, we can see how or what are the capabilities this agent actually has, so that another agent can understand what this agent does. So what we can do is we can click on this link. I'm going to paste it here in the chat. So if you have already run the command that Vanya pasted in the chat, you should be able to run this command and then gets a JSON object that describes what the agent is capable of. So let me try to do that and see if it works on my end. Let me see. Okay, so it says method not allowed, but let me try to actually add something to the URL. So let me try to add. Let me try to add well-known. Okay, so I do get something back. So this is what another LLM would see if it tries to call this LLM and try to get like agent.json.
Rohan, can you go back again? How did you get into this JSON object, please?
Oh yeah, okay, yeah.
Because
So,
many we encountered the same error.
yeah, so I realized that the URL bar is not showing up on the presentation. Okay, so let me see. So this is the link in the terminal. So if you're on a Mac, use command and click. Okay. So if you if you do command plus click, it's going to open up a new tab. It's going to take you to a weird looking URL that starts with the port number, I believe, and then it has a lot of other words as well. So for me, it looks like this. Let me see if I can paste it here. For me, it looks like this. I pasted the URL in the chat. Actually, let me paste it here. This is important. Okay. So for me, it looks like this. This is what I have on my hand. And then you could actually append dot well known / agent.json. And if you take this whole URL and put it in the URL bar, you should get something like this. You should get a URL. And this is essentially the agent card that this LLM possesses. And then another LLM could understand what are the capabilities of this agent and then call or give instructions to this agent. This agent will call the currency conversion function and then return the response to the first LLM that called this agent. Okay, so let's see. So skills are an agent can help with the currency conversion, so and so. Okay. Description, use this to get current exchange rate. So this is an LLM. This has access to tools. And this is the URL. Okay. Yeah, so this is what an agent card is. And now this agent is part of the A2A protocol. Multiple agents can communicate with this. Okay, I'm gonna go back to my cloud, Google Cloud. And now what we're going to do is we're going to test the agent. So let me see if I can actually test. So I'm going to create another terminal here. Let me comment this out. And then I'm going to do test client. Okay, so ideally test underscore client.py should be an LLM, but we will simulate an LLM, the caller LLM that calls the agent.py. Okay, so this is the test client.py file. Okay, so there are like a lot of packages here from the A2A library, and it has an A2A card resolver class, A2A client. Okay, so this is where the LLM is running. And then, oh, it's a big file. It's not that big. Okay. An asynchronous call inside main. So let's go to main. So it instantiates asynchronous client as HTTPX client, and A2A card resolver essentially points to the agent URL, which is this. And by pointing to the agent URL, so you get a resolver object here, resolver variable. And then using resolver, you can call the get agent card. And this is exactly what this script or another LLM would see. What it would see that JSON file or the JSON object that we saw on the when we clicked on the URL. Okay, so let's try to test this. If this works, we should see connection successful. And after connection is successful, it will call this asynchronous functions. It will make this asynchronous calls where it does a single turn test and it also does a multi-turn test. So what is a single turn test? Let's try to export this function. Okay, it's a single turn response, single turn request response. And what does it do? It sends a message. Okay, what's the message? How much is 100 USD in CAD? Let me, yeah, I think cat is fine. Okay, so this is the payload and this is what will be sent to the LLM that is actually now running. And then the LLM will process this response and then it will call the MCP server that is deployed on Cloud Run. It will get the response from the MCP server. It will do some processing and then it will give you the output. Okay, so let's try to do that. So I'm going to open up the terminal again. I'm going to go to the third terminal here on the right. And then I should be, okay, let me go into currency agent again. And then I'm going to do UV run currency agent test client. Let me see if this works. Okay. Okay, so there's a timeout error, which is fine, whatever. But for the singleton request, it did work. So connection was successful. Oh, singleton request, it did not work for some reason. There's some issue with the asynchronous function calls. Let me see if I can try it again. Yeah, things can go wrong. Let me run this again. Let's see if this works. Nope. Let me open this in another.
Rohan, I had this error before, and probably if you go to the snippet where there is client equal A2A client, and then you can increase the timeout parameter, so you will have more time to do the calling.
You mean in the test client?
Yeah.
Where is the timeout parameter? Timeout.
It's let me send you the snippet.
Yeah, you
So
can
you
send it. Yeah, but like this didn't happen yesterday, but this can happen. But anyway, so like the point is, this is a test client Pi that calls the LLM that is running, and then it should call the MCP server that is deployed on Cloud Run, and then it should give you the response. That is the goal. But yeah, I can keep trying the, and I can try to make this work, but ultimately that's like the goal here. So I'm gonna, let's see if I can try to fix this. But let me know. This is the end of the codelab, and if you have any questions, like feel free to put them in the chat. But in the meantime, I'll try to like fix this. It will be $0 for this specific codelab. Yes. Okay, maybe this is like a different version of the, because the code snippet that Vanya you gave me. Okay, maybe I could just add the timeout parameter. Okay. To a client. see if I can add a timeout here. There's a runtime error. Anyways, I gotta fix this runtime error separately, but
Yeah, it happened to me as
I
well.
gotta
Yeah.
find out what the error is first. Anyway, so I think that's the if everything works perfectly on your end, you should see that that the singleton requests and the multi-ton requests actually work perfectly. And that essentially tells you that the LLM agent is being successfully called by this test underscore client.py. And this is mimicking another LLM that should be calling the LLM agent, or the agent.py. So that essentially concludes the code lab. And yeah, I think we are good on time. It's 12:30. So we can end it here, I think.
Yeah, can you pass me over the screen share, please? Get back to me the screen or stop sharing so I
Oh
can.
yeah, I should be stop. Okay, I should stop.
Thank you.
Yeah.
Okay, now it's my turn. Thanks. Please give a loud clap to Rohan that he was able to instruct us all way long to this tutorial and deconstruct every function and model of this code lab. Yay! Okay, one moment. I'm trying to share my. Okay, yeah. Yeah. Well, again, a huge clap to Rohan. And before you go, I want to give you some housekeeping task. With these commands, you will get worry-free about potential cloud cost. In the first command, you will descale your MCP server. And then after you run the first command, you will delete your MCP server, so you won't see it again on the Cloud Run console. Please let me know if you have any doubts about this couple of commands. Excellent. Thank you so much. Now, please help us to get better. Fill out our survey. I'm going to drop again the link of the form. Let me invite you to our distinct social media where you can get notice of our upcoming events on LinkedIn, X, Instagram, and you are welcome to join our Discord server. We promise to keep it quiet. Oh, Rohan, here Kenneth asked if we get 2 million per container or 2 million total requests. We cannot hear you. You're muted.
Yeah, I'll check. I'll check and put it in the chat. I'm pretty sure it's total, but because 2 million per container wouldn't make sense. That's like too many requests, but I need to double check that.
Okay, thank you guys for making time today. We hope you have a great rest of your day and your evening, that you can enjoy the summer and the rest of the World Wide Cup. Sorry. Thank you so much. Have a great one. Thank you, Rohan.
Bye.